Who would I prefer? I mean, I don't even really vote, so it doesn't really matter what I would prefer, honestly. But the um, definitely Biden, just because the stupidity of what went on beforehand and all this racist crap and all this other nonsense. Like I can't put up this garbage. But the like you can't like there's some things that Trump said that I really, really, really agree with, but then he didn't do a good job doing it. But then like Biden doesn't do a good job either sometimes, but he hasn't done as dumb things. So I prefer Biden. But I mean like I don't, but honestly, like none of these dudes are really that good. So I do think Biden's better than Trump. Trump's pretty bad. No, he came up with he said that, but then he did a terrible job actually. So then the thing was that the United States ended up actually um owing more money to China because of what he ended up doing. And now some things that he did were turned out they like ended up being okay, but for the most part, it actually caused more problems. And it didn't seem to even be necessary because like there's anyway, it's just like he I don't like it when people say things that get people all riled up and like are gonna make you like agree with them, but then like they just do like an absolute stupid thing afterwards, or um they're just doing it to get votes. And like it's pretty much what he did. Yeah, but that honestly, like, I don't really care what you do or don't do. I just care if you're gonna sit there and screw up the people and all that stuff like that. But but he's not a good leader. That's the problem. Like he's not a good organizer of all these people, and he doesn't know how to work with all these people. And he's like, even if Biden is bad at stuff, he seems like he's way better than Trump. Trump is just Trump's kind of dumb. Like he's just it's kind of just stupid. All right, let's do this. So focus groups, 14 people are randomly selected to discuss let's talk about this first. All right, so we were discussing all this stuff about binomial distributions. Or actually, we hadn't started that yet. Excuse me. So we should start that. All right. So what is a binomial distribution? So a binomial distribution is the number of successes in n independent trials, given each trial has two outcomes, success or failure. The probability of success remains the same from trial to trial, or sometimes people say the trials are independent. Um, so like an example of this would be the number of heads in 7 coin flips. All right. So usually they'll say that they have these 3 rules. I mean, I said it here already, but I'm just gonna summarize them. So we say n independent trials. Each trial has outcomes. The only possible outcomes, let's say, for each trial are success and failure. We let P equal the probability of success. And Q equal the probability of failure. So if that's the case, if P is the probability of success and Q is the probability of failure on any one given trial, what's the relationship between P and Q? They're complements of each other is correct. So what would that mean? P plus Q is good also. 1 is correct. Good. So then if P is the probability of success and Q is the probability of failure, and on each particular trial, the only possibilities are success or failure, then P plus Q is going to have to be 1. Does that make sense? This would mean then also that sometimes we say that Q is just, of course, equal to then 1 minus P. Does that make sense? Right. And then I was just saying also the probability of success P is assumed to remain the same for each trial. Okay, does that make sense? If something satisfies these criteria, then it's referred to as binomial. Does that make sense? All right. So then usually what I'll do is I'll label the binomial distribution like this. I'll start writing this stuff all the time. So like xi, the random variable, is I write this binomial with parameters n and p, where n is the number of trials and then p is the probability of success, as we said before. Does that make sense? Does that make sense? All right, in this case here, what is n and what is p? Oh, first I should ask, excuse me, I guess I should say before I even say that. We should ask, really, can we even say that this is binomial? Jesus. Excuse me. Come on. Did everything just disappear? Okay. Actually, before I should even ask this, I should say, define a random variable representing the situation and explain why it is binomial or not. All right, so if we had to define a random variable in this case, so I'm going to say let x be something. Does that make sense? What would you want it to represent here? I would say let x be the number of heads after 7 flips of a coin. Okay. Now, to determine if this is going to be binomial, we need to verify if these things are true. Does that make sense? So then number 1. Is it true? Why or why not? Explain. Does that make sense? Does that make sense? So do you know what I mean by a trial first here? What would a trial be in this case? If there could be a trial. A single coin flip. Does that make sense? Okay, but it says the trials need to be independent as well. Is that right? Are they? By the way, this thing right here doesn't really need to be stated. This really is implied from 1. Because if they're independent from each other, then the probability of success would remain the same. Does that make sense? Okay, this really doesn't need to be stated. Okay, so why are they independent? Why or why not? Mm, I kind of get what you're saying, but you can't say it like that. It doesn't make any sense. So in this case, we said that the trial was one coin flip. Are the trials independent? Why or why not? One coin flip doesn't affect the other one, right? So, all right, what would N be then? There are 7 independent trials where someone flips a single coin. Does that make sense? Does that make sense? 2. The only possible outcomes for each trial are success and failure. Therefore, we have to define what success and failure mean in this case. What would success mean? Success is getting a heads on a trial. Is that correct? What would failure mean? Could be tails, but we should really just say not getting success or not getting a heads. I mean, I guess you could have the coin land on the side and you didn't get heads. Is that correct? All right. So then if P is supposed to be constant, what is P? Whoops. What is P in this case? P is the probability of getting heads on one trial. So that's 1/2. Is that correct? And what does Q mean in this case? That's correct. The probability of not getting heads, heads, I guess, whatever, on one trial. And of course, that would just be equal to, we could just do 1 minus P, and then we get 1 minus 1/2 or 1/2. Does that make sense? So in other words, if I say what N and P are, not too bad, really. Does that make sense? But you have to establish whether or not it's binomial first or not. Does that make sense? You're right. They start talking about something that they say she kind of discussed previously, believe it or not, but maximum and minimum values. Um, they say something like usually values of a distribution will fall between the following 2 numbers. The mean minus 2 times the standard deviation, and the mean plus 2 times the standard deviation. Does that make sense? Why do they say this? If you remember from before, so if something follows a normal distribution and you go 2 standard deviations to the left and you go 2 standard deviations to the right, what percentage of the data do we expect to fall within there? 95% is correct. All right, 95% approximately. Is that right? So what percentage of data would we expect to fall on the outside? 5%. That's correct. But 5% is good. All right. So the what did we say about 5% before? 5% we said was like if the probability of some event is less than 5%, we start saying then that this is like significant or unusual. Does that make sense? So if we're outside of these two values, then we would be outside, it would be over here, and we'd be over here. So this is like, if it's a normal distribution, we would expect 95% of the data to fall between these things. Does that make sense? Yeah. Of course, not everything is normally distributed, but since a lot of things end up being normally distributed, that's why this is. Question? 2 times the standard deviation. Does that make sense? Question with this? Does it make sense, guys? All right. Focus groups of 14 people are randomly selected to discuss the products of the famous company. It is determined that the mean number per group who recognize the famous brand is 8.6. And the standard deviation is 0.63. Would it be unusual to randomly select 14 people and find that greater than 12 recognize the famous brand? What would you say? How would I do this? What would you say? This one should be okay. There isn't going to be much easier in this question throughout the entire course, honestly. So if you can't do this, it means you be late reading, honestly. But this is straight reading. So it's very little to do with any math. Why? How? Says they asked 14 people this stuff, and they give us these numbers, and they just want to know, would this be unusual or would this be significant if 12 people ended up answering that they recognize this thing? Does that make sense? Yeah, but I don't want to know close and all this nonsense. I want to know how to calculate it. I just said something on how to do this. Yeah, which is yeah. Why is it unusual? What's not? So we just said before, right, that the minimum usual value and the maximum usual value. How do we calculate those two things? What did I say? The mean this one's minus, right? And this one be plus. Is that correct? And then you just said this was equal to what? Yeah. Because I mean, I don't see what honestly, I don't see why this is that hard at all. 2 times this, right? That's 1.26. 1.26 plus this, 9.86. Does that make sense? All right, I'm being sincere. Like this one, no. If this one you think is hard, you ain't trying. Does that make sense? All right, so this one, we get this. All right, now this is why. So that was the math part. Does that make sense? Does that make sense? Now it's straight reading, in my opinion. Okay? So read it and explain to me what the answer is and why. Because the problem is that not enough people are reading some of these things sometimes, and you're gonna make mistakes on this when we take the final and stuff otherwise. But if you read it now, you're going to learn what they want you to do, and they're pretty much going to keep asking the same types of questions over and over and over again. So how am I going to answer this question based off of what we've calculated and why? Does it make sense what I'm asking? And do we, like, what about this? Should we do this too? Like, or do we not have to? Why not? Explain to me. And somehow this is going to be just reading. And this has nothing to do with understanding statistics or anything. Because we did the statistics part already. And I know you could tell me what maximum usual value and minimum usual value meant before you took this course at all. Does that make sense? I know you know what the word usual means. Is that right? Does that make sense? So how do we answer? What is? 9.86 is what? So what's above it? I still don't understand. You still 12. Okay. So they say they saw 12 people out of the 14 who ended up saying that this was um that they recognize this. Is that correct? So if they recognize this 12 people, right? We just said that the maximum usual thing that you would expect to see is 9.86. Is that correct? So you see what I mean? It's just reading. Does that make sense what I'm saying? Do you get what I mean by that? Don't get me wrong. You got to sit there and think for a second when those things happen. No, it's true because it's always like they'll say something like the numbers are between here and here or whatever. You know what I mean? And then you're just like, they give you another number. And they're like, well, what does it mean? And you just start saying, is it inside here or is it outside? Does that make sense? Is it inside the interval or not? Does that make sense? So in this case, this is definitely larger than anything that would be usual. Is that correct? We don't need to calculate this. This is already bigger than the maximum usual thing. Does that make sense? So therefore, it's definitely going to be unusual. Does that make sense? You understand? Question with this? Should be simple, this thing. Does that make sense? But you're going to be happy then if you see this on the test. 1 second, I'm sorry. You're going to be happy if you see this on the test because I'm going to have to keep giving the same types of questions, right? You see this type of question on the test, I would be like, yeah, thank you. Because this one's not that bad. I can add, multiply two numbers and then add. Does that make sense? Now, at some points, they're not going to give you what the standard deviation and mean are, and you're going to have to calculate what the standard deviation and mean are, either using one var for statistics or some formula. Does that make sense? All right. So, but then you would just still plug it in here. Question, I'm sorry. Because I don't know what the mean and standard deviation of this nonsense is unless they tell me here. Like, I can't answer that. Does that make sense? Sorry, go ahead. Right, right. And that would be like 1.26 from this. That'd be like 34. Anything less than 7.34. Does that make sense? But anything between 7.34 and 9.86, we would consider to be usual. Does that make sense? All right. Question. All right. What about this one? In a game, you have a 1 out of 39 probability of winning $91 and a 38 39 probability of losing $2. What is your expected value? And how do we go about doing this a one? Do you have a suggestion? A question about the last one? Or go ahead. Probability, the probability by the value. Okay. Very close. Very close. Okay. You made one little mistake. All right. Well, It's going to end up being a big mistake, but it really is a little mistake. All right. Um, but we, but you're doing it you're remembering the formula. You're doing this like very correctly. Okay. The only thing that I don't like about it is I don't think you're 100% defining a random variable and telling me what it means, and then trying to just write out this table first. That's what I said to do previously. Does that make sense? But first, just try and tell me what the random variable means. So wait, excuse me. What what random variable would I have to define based off this situation so that it's going to answer the question I want here? Does that make sense? What would the go ahead. You can't just say a random variable is 91, then it's not even random. What does a random variable mean first? Not probability. Random variable is not a probability. Last time we just said random variable was what? The number of heads or whatever. Is that correct? Right? Um, if you say win or lose, I can't calculate anything. Does that make sense? Does that make sense? I can't like answer the question of what they're asking about here. Is that right? That's correct. All right, that's where you made the error, Cheval. She just said you're going to gain $91. You're going to lose $2. This should be -2. Okay. But still, you still haven't defined what the random variable is. What would the random variable be in this case where something is 91 and something is -2? What is it? What does it mean? If x is either 91 or -2 in this case, what does it mean? You're right. X is supposed to be 91 and -2. Just tell me what this is supposed to be representing. You don't have to say anything about probability, nothing. I'm just asking you what these numbers mean. What is it? How would you define a variable that represents those numbers? What would the variable mean or be about? What did you say? Sorry? The money what? The money. You say that to somebody, does anybody know what you're talking about? Sure. How much money you got after playing the game, the winnings after playing the game. Is that correct? Does that make sense? The amount of money after playing or whatever. Does that make sense? It's random, right? You don't know how much you're going to have. Is that correct? But you either going to have 91 or you're going to have -2 each time you play. Is that right? Does that make sense? But not +2, right? So then you're correct. The probability of this is 1 out of 39. And then the probability of this was no. Yes. The probability of this is 38 out of 39. And then if you want to, you could just multiply this. So you get 91 over 39. And this is -76 over 39. So then we end up adding these two things up. And then we get, what is this, 15 over 39. 15 over 39. What is that? 3 over 8. So that's like 38%, 39%, something like that. Does that make sense? Okay. Oh, excuse me. I'm not, I shouldn't be saying 38%. This is approximately how much you're going to win each time. About 38 cents, 39 cents, something like that. Does that make sense? You didn't have to do it this way. You didn't really have to remember the formula. What did we say we can do also? This is getting silly, guys. Yeah, use the calculator. Just type this stupid crap in and then just do one bar stats and it'll tell you the answer. Is that correct? Don't forget that. Please. That's why we were letting you use the calculator. Does that understand? Got it? But what you have to be able to write this thing first. Does that understand what I'm saying? Either way, if you use the formula or if you use the calculator. But if you go and be able to write this thing and just type it in, just do one bar stats. Does that make sense? Good, guys? Question with this? Does that make sense, guys? All right. Rolling a single die 44 times, keeping track of the numbers that are rolled. Is this binomial? Why or why not? Read it. 13. Why? So what do we say? We can only have a success and a failure. Is that correct? There's no success and failure here. And there's greater than two outcomes. So both of those are reasons why this can't be binomial. Does that make sense? Binomial. Is that correct? Does that make sense? Right? Trinomial would mean there would be three choices. Is that correct? All right, we don't want to do that. I guess more. Well, not that much actually, but does that make sense? All right, rolling a single die 49 times, keeping the track of the number of fives rolled. This one is binomial, is correct. Because now just remember, all you need is n independent trials, each one with success and failure. Does that make sense? So there's n independent n trials, right? They're independent because we're just saying we're rolling a die over and over and over again. It's not like if I roll a die the first time, it's going to affect what I get the second time. Does that make sense? And then you're keeping track of the fives being rolled. Well, that means what would success mean in this case? You get a five. Failure means, yeah. And well, anything but a five is correct. Good. All right. Spinning a roulette wheel 10 times, keeping track of the winning numbers. Not binomial. Because it's the same thing as the original thing. Keeping track of the winning numbers doesn't mean that I'm defining a success and a failure. Does that make sense? There could be lots of different winning numbers. The person, so roulette, there's different ways that you could get winning numbers in the game. Like roulette. So like, believe it or not, this thing we were talking about right here is similar to this game roulette. All right. So roulette is this game. If I show it to you, you'll know what I'm saying. This thing. Does that make sense? Where they like spin the thing and then they like throw a ball in there or whatever, and wherever you bet on like what it's gonna land on. Does that make sense? So there's like 39 slots, and one of them is the one they're saying you're gonna bet on in this game here. Does that make sense? All right. So then here, if you threw the ball in there and you're keeping track of the winning numbers. Oh, this time it was 30. Next time it's 2. Next time it's 5. What the heck is success? Does that make sense what I'm saying? Like there's no success on each trial. If I say to you, you want to see how many times 38 came up, or excuse me, I don't even think there is a 38. But if you want to see how many times 30 came up, okay? Yes. It depends on what they're betting on. Because you could bet on like black, you could bet on red. Like so, like there's other things you could bet on. You could bet on all the even numbers. You could bet on all the odd numbers. You could bet on all the numbers divisible by 4. You could bet on whichever numbers are your favorite ones. Does that make sense? So it's like it's not going to give you the same chance then, right? Does that make sense? So but that's not the point. The point is this. Winning number would mean whichever number it lands on. Is that correct? Okay, you're keeping track of them. What does that have to do with success and failure? Does that make sense? Nothing. Okay, right? You get it?
I just read about for keeping track of your amount of success. That's all I
Yeah, but that's not the correct way to read it. Does that make sense? But I get what you mean, but they would have to say what success. They would have to say what you're doing then. They have to say each time I'm betting on 4. Each time I'm betting on a number, one number. Then you have the same chance each time. Does that make sense? Then they shouldn't be saying keeping track of the winning numbers. They should be saying keeping track of how often you win. Right? Winning numbers means whichever number it landed on. Does that make sense? But anyway, you get what I mean, though. All right.
would it be correct if it's
Yes. Yes. Because 4 has the same chance each time. If you get a 4 one time, it doesn't affect whether you're going to get a 4 or not next time. So keep having the same chance. There's a fixed number of trials they stated there, whatever it was, 10. It's not like someone sat there and was like, "Oh, we're going to keep playing until we get it." Right? They're just saying we're going to play 10 times. So there's an end. Does that make sense? That's fine. Okay. You just got to always ask yourself if there are n independent trials. Okay. All right. Now we got to calculate some stuff. All right. So let's say binomial probability distribution. All right. So we already talked about this before a little bit, but I'm just going to rewrite this. Xi is binomial with parameters n and p, means Xi is the number of successes on n independent trials, each having probability of success p. Does that make sense? So then trials, you either have success or failure on each one. Okay. Now the next thing is they're going to say is we need to calculate the probability. Does that make sense? Does that make sense? All right, I'm going to first do this with sort of an example, and then we'll write out all the formulas. And then we'll say how to do it on the calculator also. Okay. Again, this is not the point yet where the calculator is going to still be a place where like you're not, you can do it. You actually can answer all the questions without this calculator still. Okay. But it becomes longer. Like if I use a different calculator, all right, a lot longer for some of these. Okay. And the next chapter though ain't gonna work. Does that understand? All right. And then for the rest of the class. The brand name of a certain chain of coffee shops has a 47% recognition rate in the town of Coffleton. Coffleton. Okay. An executive from the company wants to verify the recognition rate as the company is interested in opening a coffee shop in the town. He selects a random sample of 7 residents. Find the probability that exactly 4 of the 7 recognize the brand name. Does it make sense? All right, now we need to start trying to define a random variable first. Does that make sense? All right, so what could we say we need here? Or what's like the random thing that's happening here that we need to talk about to try to answer whatever the question is they're asking here? Say what I'm saying? They, who are they? Well, like all of them? But four is not, 4 and 7 is what they're asking about. Is that correct? Does it have to be four each time? No. So what's like the random part then? Whether they do what? Whether the 7 recognize the brand name or not. That's like the random thing. Is that correct? But I need to define as a variable that's going to give me a numerical answer. So what would that be? How would we define this variable here? X is what? The number of residents that recognize. Does that make sense what I'm saying? You guys are all saying the right stuff, but you just got to mention that one word extra. Does that make sense? Because you didn't say the number. You just said whether they recognize or don't. It's true. That's like the random thing that's happening, but I need a number. Does that make sense? Right. You get what I mean though? Okay. The number, but specifically out of the 7. We're grabbing 7 people, not just the number of residents, right? First of all, the number of residents that recognize is not random. Does that make sense? There's this people here, you either recognize, you don't. Is that correct? That's not random. Does that make sense? But if I go grab 7 people out of this group and then ask those 7 people, unless everybody either recognizes it or everybody doesn't recognize it, that part's going to be random. Does that make sense? You understand? You get what I just said or not?
Yeah.
Okay. So then the thing is the number that recognize the brands out of 7. Does that make sense? Okay. I'm just trying to be very specific, but it's really important. If you're specific, you'll be able to calculate it. You'll know what it means. Does that make sense what I'm saying? If you're not, you're always going to sit here and kind of be confused. What are we talking about? Why are we talking about this? Does that make sense? I'm just trying to say to you that please try to think about what that variable really represents. Does that make sense? Then each time it'll be similar. And then you'll be like, wait, it's the same thing. Does that make sense what I'm saying? Like, what's the difference if I sit here and I was to say to you, we're flipping coins, 7 coins. Is that correct? And I want to get 4 heads. Does that make sense? The only difference would be is that this thing would say 50%. Is that correct? Does that make sense what I'm saying? You get what I mean? So the problem is a lot of questions that you would be able to say a binomial distribution is really going to somehow start discussing the answers. Does that make sense? They want you to just be able to recognize it. Once you recognize it, then we're going to talk about obviously how you calculate it, but you're also going to have a way to do it on your calculator. So all you have to do is recognize it. Does that make sense? You got it? And then like, there's like a lot of these different things. Well, we don't do that many in this class, okay? But there's a lot of these different types of probability distributions. And then if you got good at recognizing them, then all of a sudden people pay you money to do this. Does that make sense? Swear to God. All right. No, you'd be surprised. Okay. No, there was this test I took. There was an actuary test thing. Oh, it's hard. You gotta do calculus and stuff like that. But I don't know. You see this math competition stuff? I didn't study. I didn't do that great on it, but I passed. All of a sudden, you pass a couple of these tests, they start paying you $80,000, $100,000 a year, just like that. And all I'm saying is that I've seen some pretty dumb people be able to do it. Way dumber than any of you guys in here. So all I'm trying to say is that you just don't realize you don't even know that these things are out there. Does that make sense? And then the point I'm trying to make is that like, oh, people are like, oh, what are you going to use this bullshit for? I'm like, yeah, you're probably right. But at the same time, I hope you do. Because if you do, you're going to make a bunch of money doing it. I promise you. Does that make sense? All right. Because you see what these things are for. Oh, by the way, another thing. So like there's a lot of like all my kids at the other school, they're always trying to get all these fancy jobs and go to these colleges and whatever and stuff like that. This girl, she sat there, she just got a job. What is she at? How many years she had? 2 years. So I think it's gonna be our third year in college. Okay. And she got a job just now. She's getting paid $250 now an hour. All right. And she wasn't even that good, to be honest, when I was teaching them. She was really smart when she first got there, but she didn't do anything. She wasn't even that good after a while. And uh, how quickly a person can process something. So the not actually not just that, how able they're also to. It's related though, but how able they're also if they're wrong, how their ability to change their mind and realize they're wrong. Does that make sense? No, just make realize they're wrong. Accept the other side. You know, you believe something, you're sure you're right, and all this stuff, and then all of a sudden somebody's proving you wrong right in front of you. Sometimes it's hard to see it for a while. You know what I mean? So it's like that. But if the person can't do that, how smart can they really be? Does that make sense? So like but you know, everybody has problems. You know, it's gonna happen. So I'm just saying these types of situations, I feel like you can tell if someone's how smart the person is, maybe. You know, of course, there's a lot of other things that go on, so who knows? But some finance job. But my point with this, what I'm trying to say is that the reason why she ended up getting the job was because they gave her an interview, and when she had the interview, they started asking her these dumb math problems, and she was able to answer them. And the point that I'm trying to make is that you don't know what you're going to need later. And you don't know what the person's going to turn around and start asking you to be able to do to get the job. Does that make sense? And usually, all they're going to really want to be able to see is that you can think. Does that make sense? You get what I mean by that? Like these Google interviews and stuff like that, they ask these ridiculously crazy questions in some of these interviews. I mean, they're hard questions, but they sometimes don't even have an answer, or no one knows the answer. People have spent their entire lives trying to figure it out. They ask you the damn question in the interview. You start explaining how you're going to start trying to answer the question. And then if you explain it in a reasonable way that you can start breaking it down and showing someone how you'd be able to distinguish between right and wrong and stuff like that, then all of a sudden then the person's going to turn around and be like, sure, come over here, right? So like but no, but seriously, right? What because they give you these IQ tests and stuff like that, and I'll tell you right now, those things are absolute bullshit. All right, like, oh, I want to see how smart you are. See, that's why I kind of like scoffed when you originally asked the question. I mean, like, what the hell does smart even mean? Does that make sense? Like, it's like, but there are some people that you put them in certain situations and they just seem to figure it out. Does that make sense? Okay, fine. Those people are smart. It's just like, how many of those people are there? Not that many, really, right? But um, but there's a lot of people who cannot or don't let themselves process information that's right in front of them, that's right around them all day, every day. And then it gradually the person starts having difficulties. Does that make sense? And then people start calling this person not smart or whatever. But it's really just if you just keep having an open mind, I feel like. Does that make sense? Like it's just like, are you going to keep listening? If you keep listening, you're obviously going to keep getting smarter. You know what I mean? If you sit there and you start shutting things down and you say, I'm not going to listen, I'm not going to pay attention, then yeah, sure. You can only get dumber, right? So anyway. All right. XI is the number of that recognize the brand out of this thing. So they want us to determine the probability that XI is going to be 4. Does that make sense? All right. The way we're going to end up calculating this, let's just define the random variable. This is binomial. What are N and P? What does N mean? Number of trials. What are the number of trials in this case? 7. What's P? The probability of getting someone that recognizes it's going to be 47% on any given trial. That's what they said. Is that correct? Right? They didn't say for like Bobby or Joe or Steve or Susie or whatever. They're just like, 47% of the time someone's going to recognize. Does that make sense? But nice. All right. So this is binomial with all this stuff. Does that make sense? Again, this is what they want us to calculate here. They want us to know what that is. Is that right? All right. The way we're going to try to calculate this, well, I don't know. What would you think to do first? This is really something that now has to do with the chapter 4 stuff. Sorry. You can't say 4 times. Because if you start saying 4 times the thing, then it's like really adding them. Does that make sense? This is not an or situation. And then that's it. What about the other 3 people? So you're kind of saying something like this. I mean, you're both kind of saying something like this. The only thing is you need to multiply. Does that make sense? Because it's and. The first person needs to recognize, and the second one, and the third one, and the fourth one, but not, and the fifth one needs to not, and the sixth one needs to not, and the seventh one needs to not or. Is that correct? Does that make sense? But there's a problem with this. What's the problem? Why can this not be the answer? Why is that not right? Close. There's something that we have to do a bit more because this is not enough for some reason. Why not? Is this the only way possible? What do you mean? Huh? You guys are shaking your head no. What do you mean? No what? Just because I say that, you start saying no? Is this the only way this could happen? Obviously, the answer is no if I'm asking this, but why? What else can happen? Something very obvious. Go ahead. A different order would be correct. The first four people have to be the one that recognize? Just has to be four of them. Is that correct? So let's just move this down a little bit for a second. What other way could we do this? Sure. And this would be a different way also. Is that correct? What would be its probability though? Same thing. Is that correct? No matter which combination of these things I do, it's going to be here. There's going to be p to the power of 4. And it's going to be q to the power of 3, or 0.47 to the power of 4, and then 0.53 to the power of 3. Is that right? The problem is though that we need to still calculate the number of we need to still calculate the number of ways that this could happen. Because there's lots of different ways we could do this. Is that right? You have a suggestion? Wait, does everybody get what I'm saying first? Like this one's going to give me this probability. This one's going to give me this probability, right? So like if I just knew how many ways there were I could do this, is that correct? And I just multiply by whatever this stupid number is, right? It's going to be the answer. Does that make sense? Go ahead, sorry. Divide what by? This whole thing? This thing here, I mean? Isn't that going to make it smaller then? Should we have the number be smaller than this? This is just the probability of one of these ways. Is that correct? It's definitely going to be bigger than this, not smaller. Does that make sense? Do you understand? Because you're dividing by something here. I'm saying I'm going to have to multiply by something. Is that correct? How many times? What can happen? Just be specific. Pretty much. There's how many ways there could be 4 people who recognize out of the 7. Is that correct? You understand what I'm saying? You guys get the question? We calculated this, you get this probability. We calculate this, you get this probability. If I found out how many of these things there were, right, and each one of them keeps giving me the same answer, all I'd have to do is add these up, which would just mean this times something. So I'm just asking you what the times something is. Does that make sense? Using the stuff in the previous chapter. All the counting stuff. Does that make sense? So what did we say when we were doing counting? We only talked about 2 things. We talked about what? What were the 2 things? There were 2 things that we talked about when we were doing counting. Permutation and combination. Is that correct? And I said you can pretty much just answer all the questions based off that stuff. You just know which one to use. Is that right? All right. How do we determine between permutation and combination? How do we determine what to do? Go ahead. Combination was a group is correct. Current permutation was an arrangement. Does that make sense? Permutation, the order mattered. Combination, the order doesn't matter. This is definitely a combination is correct because the order doesn't make any difference. Good. Does that make sense? All right. But another way you can just say it is you can just say, hey, I need to pick groups of the 7 people, size 4. We're going to say yes. Does that make sense? The rest of the people I just say no. Is that right? So you were close. But that's bad because you can't tell me you're gonna divide. Does that make sense? Do you understand? All right, so then all I'm gonna say here is 7C4. So I have to choose 4 of the successes. So it needs to be 7 factorial over 4 factorial, 3 factorial. Big difference though. Does that make sense? You can't tell me you need to divide here. Do you get what I'm saying? All right. Does it make sense, guys? 7 trials. 7 things. You gotta choose 4 of them. Is that right? All right, so this is the same thing as saying 7 times 6 times 5 times 4 all over 4 times 3 times 2 times 1. So this cancels, you get 35. So this is 35 times this. Sorry, I just can't tell if this calculator is 100% working correctly, but I think it is. All right, so this, I got the same thing. Does that make sense? Or excuse me, this is what I got for the answer. So 25.4% of the time, we would expect 4 people to recognize if there was a 47% recognition rate overall. Does that make sense? Do you understand, guys? Question with this so far? Do you guys get it though? All right, let's just write out the formula real quick, okay? Question? Does it make sense? All right, so if we wanted to write out a binomial probability distribution, the thing we would need is I would need to be able to say what the probability was on each individual. Well, not on the trials, because they're already going to tell me that, like what the chances are going to be. But what's the probability that you're going to get 5 successes? What's the probability you're going to get 6 successes? What's the probability you're going to get 7? What's the probability you're going to get 4, 3, 2, 1, 0? All the different possibilities. Does that make sense? Yes, that's correct. So then the so we write it like this. Okay, they write it like this, right? Where the random variable needs to be equal to x, where x is a certain number of successes. Okay, so like this kind of gets annoying, but it's makes sense if you think about it. Okay, x is the number of successes. If you remember this, this ends up being helpful throughout the rest of the course. Does that understand what I'm saying? All right. I'm going to bring it up again and again though. We're going to talk about it more times. Okay. So like, but this, if I say this is the random variable, right, equals this number of successes. Does that make sense? All right. Then the way we said we're going to calculate this is I say the number of ways, right, times the probability of one way. Does that make sense? Does that make sense? Then this is going to equal to, they say, NCX times P to the power of, I'm going to just write this because I don't want to write it in this stupid typing. NCX times P to the power of X, Q to the power of N minus X. If X is the number of successes, then N minus X is what? The number of failures. Is that correct? Like if you have like 1, 2, 3, 4, 5, 6, 7, and then we were saying like success, 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 success. So then in this case, X would be 4. Then this would be failure, failure, a failure, right? N minus X is 7, minus 4 is 3. Does that make sense? the number of Qs. Is that correct? Right? This is what they say the formula is. Does that make sense? Using the numbers we just had before. So in other words, all you really have to be able to do the question is recognize this binomial, be able to say n is 7. Does that make sense? Be able to say that the recognition rate on each trial is 47%. That was given in the question, right? And then they want 4 successives. X is 4. Does that make sense? Does that make sense? Question so far? All right. Throughout the rest of the course, they're going to keep talking about these things also. They're going to talk about a probability distribution function, which will be abbreviated quite often as just PDF or PMF. PMF is usually what people say when it's discrete. What is a probability distribution function? So we say f of x is a probability distribution function if it actually, let's just say probability mass function for now. F of x is a probability mass function if it represents the probability of x occurring. Okay? So in other words, this is really just the same thing as saying the probability that x equals to x. All right? Does that make sense? Some random variable is equal to this number x. They say that you have a cumulative man, I thought that word has 2 M's. Cumulative probability mass function, which people will say CDF. They start calling this capital F of x. All right, so this means the probability that x is less than or equal to some number. Does that make sense? Cumulatively, up until a certain point. So I can say, what's the probability you're going to be 15? And then I can say, what's the probability you're going to be less than or equal to 15? They name these things. Does that make sense? Does that make sense? Do you understand? Yeah, right. Now this part, if you don't like this part, I don't know what you're paying attention to. Because this is going to make this a joke. All right. Where do you think I should go on the calculator if you had to guess? If you remember, we talked about there's a few buttons in the calculator we're going to use. We said this at the beginning of the year. Which button do you think I'm going to use if you remember what I said? Nope. Well, if it's not that one, there's only a couple of other buttons we said. What are the other buttons? VARs, true. But VARs, yeah. There's a button here that says Dister. Does everybody see that? Right? Does that make sense? That's the one. Second, Dister. Does everybody see that? Second VARs. Second VARs. The buttons say it right here. That's what I'm clicking. All right. This is so messed up. This is a software you pay for. No, of course not. But the thing is but you're supposed to pay for it. Okay, so then I mean, I just downloaded it before, but then they just started giving it to me for free. I was like, I already have it anyway. But this thing, like, I can't make it bigger. I cannot make this bigger for you. You get what I'm saying? But the ghetto software that I've downloaded illegally, the other one, I can do whatever I want. It's so stupid. It's not even funny. Like, because it's kind of illegal. Even though I have like, I don't actually, no, I don't think it is actually, because the thing is that I have like 15 of these calculators, so technically I own them, so I'm allowed to use the emulator software. I posted it actually online on your stuff, which that part I'm not really supposed to do, but you're supposed to purchase the calculator anyway. So technically, if you purchase the calculator, it's okay for you to have the emulator software. But at the beginning of the year, I feel like it's good for people to have that before they get it. You know, they can't buy it yet, right? But there's some minor issues with that software. Like it'll start tweaking out and just shut off and stuff like that. So like, but this one's a little prettier for the rest of it. But anyway, you can't read this crap. Anyway, all I clicked was second district. All right, so I don't know. Look on this list. Tell me which one you think it is. I don't know. Just read the list. Two? Nope. Nope. Read through the list. Come on your calculator. You got your calculators. Yeah, it says binomial. These two say binom. Is that correct? Does everybody see that? Which one's it going to be for this question? Sorry? Why? We said this equals to 4, not less than or equal to 4. Is that correct? Is that correct? CDF was less than or equal to. Is that right? So I click binom PDF. Does everybody see that? All right, these numbers shouldn't be here already. I guess I just did this before with some other class because it's the same stupid numbers. But this should be the number of trials. Great, it's 7. P is 0.47. The number of successes is 4. And then you push enter. And then you push enter. And then it just gives you the answer. Does that make sense? Does that make sense? I really don't think there is much easier than that. Does that understand what I'm saying? When I was in middle school, they made me calculate all this crap over and over and over. And much harder than this. Much, much harder. Okay? Yeah. In sixth grade. Much harder than this. But then for algebra. But it was a special math program. But the thing was that, but I'm just telling you, they made me do it. All right. And there were these kids in there, I'm telling you right now, still know some of the kids. They're not that good at math, some of them. All right. Like they never were. All right. They're kind of smart. They were never good at math. All right. Like this guy, he writes for the New York Post. He's a good writer. All right. Now he's my friend, but he'll tell you right now, he's not good at math. Okay. And these kids could do it when they were in sixth grade. And all I'm trying to say is that the kid was smart. I'm not saying he's not smart. He is. All right. But he's not good at math. There's no question. I have no question in my mind There isn't a single person I've ever explained this stuff to that they can't do it. Do you know what I'm saying? All right. Do they remember? They do enough practice? Whatever. Does that make sense? All right. Question with this though? You get it? But you understand why I'm saying it this way. First, I want you to understand how it's actually calculated, how it works, right? Then the thing is what's going to happen is like your math lab is constantly going to say just this. It's going to go through like 800 pages of explaining this each time. Does that make sense? First of all, you shouldn't need that. If you are reading that over and over and over again, you're going to confuse yourself. Does that make sense what I'm saying? Yeah, when you put view an example or anything like that, it starts giving you like 20,000 things on it. Okay? Yeah. And then it starts explaining the entire thing. Same exact thing the way it explains in the book. But students don't want to read the book, so it gives you it that way. They think they're getting something different. It's the exact same thing. The book's actually better. But it goes through the whole thing, right? People don't understand what it means. So they start reading it, and then honestly, it's more confusing because they start trying to explain each line. And then people start getting even more confused. Because then it's too much reading, and they just don't stop reading it all. Okay? And then they completely forget that you can just do this on the calculator. Don't do that. There's a reason why I'm showing you this. Does that make sense? And I'm telling you, I can do every single one of them this way just fine. But I'm trying to make it easier so you don't have to do it that way. I'm trying to show you to use the calculator. Does everyone understand? Otherwise, you can't recognize. Once you can recognize, though, and you're sure you can do it, then yeah, I would do it on the calculator. You believe it's binomial. Does that make sense? Okay. It writes, a test consists of 10 true false questions. To pass the test, the student must answer at least 7 questions correctly. If the student guesses on each question, what's the probability the student will pass the test? All right. So in this case, I would define, or I think the most normal thing would be that you say that the random variable is going to be the number guessed correctly in 10. Does that make sense? Is this binomial? No, you can charge them. You should be happy. Then you don't have to buy stupid batteries. Yeah, what, you want to buy batteries? What kids used to come when I was in school, right? And they had to buy these stupid batteries. And everybody freaking calculator would die the day you take the damn test. Okay, so you come in there and there'd be these 4 kids who have like 800 pencils and like 900 extra batteries. They won't give you the batteries. They'll be like, no, I gotta save my batteries. Like, what if my calculator dies during the test? I'm like, yo, I got no calculator. Please, sir, please. I got my calculator right here, but these batteries don't work, right? And then you go up to the teacher and you'd be like, yo, teach, the batteries just died. Like, what am I gonna? I can't predict this. You know what I mean? What's the probability? No, but they say something like that, right? And then I walk up to the teacher and I say it to them, and then teacher will turn around to me and they used to be like, sorry. At least you have this bullshit, okay? Because I can take this cable out of my damn backpack and give it to you, and then you can charge a stupid thing when you're taking the test. But oh, you got batteries? Like batteries suck. What the hell are you talking about? Calculator lasts way longer than any PSP. Yeah, I can take that calculator and throw it against the wall like 15 times, it'll still work. I swear to God, those calculators are like those calculators. I'll take it, I'll step on it, I'll smash it against the table, guarantee it still works. Swear to God. Swear to God, those things are super strong. Trust me, I've done it. Why? Because they always give me more of these calculators. People don't believe me. They're like, "Oh, my calculator doesn't work." I'm like, "Look, bang, 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 it still works." So like the no, they just those things are they're very well designed for students. Let's say. Okay. So this xi the number guessed correctly in 10. Oh, also the reason why I remember is when I was in college, like all these kids after they bought these calculators, they're like, "Yo, I'm gonna destroy that thing." So we finished the school, we finished the class, and after the class, they're like, "I'm gonna destroy it." I'm like, "Why don't you just sell it, dumbass?" But they're like, "I'm gonna destroy it," right? So then they sit there and they like mash it on the ground, the piece breaks off and stuff like that. I'm like, yo, does it still work? We pick it up, it still works. I'm like, they get mad. They smash it on the ground again. Anyway, all right. So all right. What xi is the number guessed correctly in 10. So in this case, they want the probability that x is going to be at least 7. So this is greater than or equal to 7. Does that make sense? Does that make sense? In this case, this variable is binomial because each of these trials is independent from each other. Each trial has probability of success 1/2 because we're going to guess and it's true false. Is that right? Does that make sense, guys? Now, this is the reason why it's a little harder to use any other calculator other than this one for this test. Because the question's like this. Because this is going to say, this one's kind of easy. I could do this probably in my head, honestly. But this one, because all the numbers are going to be the same. It's always going to be 1/2 to the power of 7 times something. Okay. But the thing is this is kind of annoying if you think about it. Because it's like you have to calculate the probability you get 7. You have to calculate the probability you get 8. You have to calculate the probability you get 9. You have to calculate the probability you get 10. You have to add all those up. Does that make sense? Does that make sense? Because at least 7 successes. Is that correct? You get it? It's really 7 or 8 or 9 or 10. Is that right? But that's four different problems I would have to do. Does that make sense? To get the one answer. Is that right? Well, so I make this joke, but honestly, the joke's getting a little old, and don't even know if anybody gets the joke anymore. Okay, but Beyonce made this song back in the day. Sorry, that's true. All right, but the that wasn't the one I was thinking about. All right, she said this. I don't remember what the name of the song was, but she keeps saying like, to the left, to the left. Touche. I'm not a big Beyonce fan, honestly. I don't know about that. So I don't know about that there. All right, so the boy knows it's Beyonce. All right, so it's all right, it's all right. Jay-Z will be happy. All right, so the so Beyonce said this song, like, she was talking about something, whatever she was talking about, but what she meant about it, you didn't realize when you heard the song, but it was about statistics. She was trying to explain to you, like, cumulative distribution function is always everything is to the left. Okay, so like everything in statistics is to the left over and over. What, Jay-Z? I'm telling you. So like the everything in statistics is always to the left. So like they start doing like this nonsense. If I say this is 1, 2, 3, 4, 5, 6, 7, if I say the probability that x is equal to 4, then maybe it's like this thing. Does that make sense? If I say the probability that x is less than or equal to 2, it's like these two added up. So the problem is that like there's always these functions defined on every calculator, computer, and all kinds of stuff like that. And you have to use this stuff all the time when you're calculating. So instead of doing it each time, I'd rather make the computer do it for me, right? I know it's going to be correct. I don't have to think about the formula. I just tell it to do it. Is that right? So they always program these two types of functions, this PDF thing and this CDF thing, okay? Where PDF is like just the one thing. CDF is like up until a certain point. Does that make sense? Up until 2. Just one of them. Yeah. Up until some number. Does that make sense? But then this is to the left. Is that correct? This is left of 2. Is less than 2 is left of 2. Is that correct? Right? So then like not with the functions. They'll ask you to calculate it, but there won't be a function in the calculator that's going to do it for you. Does that make sense? The calculator only says PDF and CDF. Is that right? Does that make sense? So I want to use PDF and CDF to answer the question. I don't want to do this with PDF because I don't want to do the 4 different problems. I mean, I could. All I would have to do is just do binomial. This is 10. This is 0.5. Then I have to write 7. Then I have to do it again with 8. Then I have to do it again with 9. Then I have to do it again with 10 and add them all up. Does that make sense? But we don't have to do that. That's the whole point of having the CDF function. How can I use the CDF function to answer this? How can I use less than or equal to answer this? You understand what I'm asking? I want to use the complement is correct because the complement of this is going to be less than or equal to somehow. How can I use the complement though? So this probability here is 1 minus what probability? X is less than or equal to 6. We should say 7 first. Okay, that's the true complement. Does that make sense? Then after that, we could say that because this variable is discrete, you're right though, you would get that this is less than or equal to 6. Does that make sense? Complement of 7 or more or 6 or less. Is that right? So this is 1 minus then binomial CDF. Binomial CDF takes 3 things, N, P, and X. What do I write here? What's N? 10 is correct. What's P? That's correct. 0.5. What's X? No. 6. We just said this number here. Does that make sense? Complement of 7 or more. So now we have to get 6 or less. Is that correct? So then the calculator tells you when it's less than or equal to this, some number, right? You just tell it the number. And it's going to be like, thank you. Beyonce says to the left. Does that make sense? No, the only reason why I'm saying this stupid thing is because it's always to the left. So when they give you a question and it's something about to the right, you just have to somehow use to the left to answer it. Does that make sense? Because the calculator's only going to tell you to the left. Right. Just like we did, which is the same thing we did before earlier. If they're asking usually for a bunch of events or something like that. Yeah. Either one. 1 minus dister CDF. This is 10.5, 6. Oh yeah, also like the calculator used to not have these menus in there. This is a menu. It's letting you like choose stuff. Does that make sense? It used to not have this. It used to just be this. We just start saying binomial CDF, and you just have to remember how to type it. Does that make sense? I'll show you. It would this part. It would get to here. It would come to here. You would type binomial CDF. And by the way, this is how all like programming languages work. Like if I show you I could do this in the programming language, maybe I should show you.
With the number somewhere.
I don't know if you're gonna be able to read this shit so small. All right, so like this thing, this is some stupid programming language for statistics. Okay. So like if I sit here and I start saying, see, I can't remember the names now. Second vars. P binomial, whatever. Binomial CDF is correct. 10.5 and 6. It was 1 minus also. We're gonna talk about that in a second. So this is if I say D binom, okay? Then I start saying the number of trials, 10, success. I'll do the last one since we just calculated the last one. 7, they tell you. They tell you right here. Sorry? No, that's a separate file. The online, they put all the documentation online to explain to you how to use it. Sort of, you just start memorizing it. You do it a couple times, you start remembering. So this is X size probability. Does that make sense? All right. So they changed the order. It's not N sizes trials is correct. This is P. Does that make sense? And then this is the number of successes. Does that make sense? So the number of successes in this case we wanted, what was it? 4, then it was 7, then it was 0.47 or whatever. That was the other question we were doing. Is that right? And then you see it gives me the same answer. Does that make sense? But the point I'm trying to make is like every computer works this way. Does that make sense? Whether they tell you to order is one way or the other way, who cares? Right? You just got to know what they want you to type. Does that make sense? Yeah. So we were here. So 1 minus binom CDF. And then I said that the number was, what was it? It was 10. And this was 0.5. And this was 6. And then I got this answer. Does that make sense? Yeah. You didn't do 1 minus. Got me? 0.8, whatever, is the chances that you get 6 or less. We want to get 7 or more. Is that right? Okay, so then now you asked a very good question. Okay. So in this case, you started saying that like, oh, we wanted to say that this is greater than or equal to 7. Is that right? So we have to say 7 or more successes, right? But that's the same thing as saying 3 or less failures. Is that right? So if I make another random variable and I start saying that variable is the number of failures in this case, or the number not correct in 10. Does that make sense? Then the probability that y is going to be less than or equal to 3 is the same thing as asking x is greater than or equal to 7. Is that correct? Does that make sense, guys? This, though, is in the form binom CDF already. It's already less than or equal to. So in other words, we could just do binom CDF already here. Then there's still 10 trials. Now there's what NP, P is still 1/2 because the chance of failure is 1/2 now, or not correct. Then the chance that 3 or less here, and that'll give us the same answer. Does that make sense? Does that make sense? Question? All right, there's these 2 formulas they want you to know. Right now, I'm just going to tell you the formulas. Maybe next time I'll derive them. I don't know. I don't know if I want to. I don't know if people are going to want me to. I think people get mad sometimes when I start doing all this algebra. Next time I'll do it. We have time next time, but I just want to. All you really need is the formula. The idea is going to be helpful for the rest of the class and to understand some stuff and all that kind of stuff. But truthfully, all you need is a formula. All right, to do this stuff. So binomial probability distribution parameters. Okay. You guys remember what parameters are? What does parameter mean? Do you remember? Sorry? That's true. It has something to do with the population. No, really just like anything about the overall population. So like the mean, the standard deviation, but about the overall population, not about the sample. Does that make sense? Anything about it. Like it could be just like there's a population, right? If you do some sort of calculation based off the sample, that's called a statistic, right? If you do some calculation based off of the population, you have all of the data. It's called a parameter of the overall distribution. Does that make sense? So like in this case, the binomial distribution has a mean and it has a standard deviation. And it turns out we'll be able to figure out these formulas and they're really not that hard, some of them, all right? Especially the first one. Now, the first formula, believe it or not, if I ask you this stuff before we started doing it, not the formula, but if I ask you the question, you probably would have got it right. All right. But this is just n times p. Okay. Standard deviation is n times p times q, or sometimes people write n times p times 1 minus p. Does that make sense? What would the variance be then? What would the variance be? If you square this, you would just get npq. Is that correct? Or I guess we could also write n times p times 1 minus p. This formula is very easy. Does that make sense what I'm saying? All you have to do is be able to say something is binomial, say what n and p are, and then you get the answers. Does that make sense? You just do it on your calculator. Does that make sense? Does that make sense, guys? Solve the problem. The probability is 0.7 that a person shopping at a certain store will spend less than $20. For groups as far as 29, find the mean number of people who spend less than $20. And this is the one that I think you should be able to do without taking the class. You should be able to do this question without taking this class. Number 18, this specific question. Cool. I'll explain why afterwards. And then you'll tell me I agree. But come on, how are we gonna do this? Let's go. Nope. What did we just say for the formula? Didn't I just say mean right here? Why does that have to be the answer? Why am I saying this should actually be easy? Why am I saying that you should be able to do this, believe it or not, without taking this class at all? Why? All this is saying is 70% of 29. Is that correct? That make sense? If they say 70% of the people and they tell you it's 29 people, then you just say, okay, 70% of those people. Is that right? But that's what the formula means. Does that make sense? All right, what is this? What's 29 times 0.7? What is that? 30 times 0.7 is 21, so it's just 20.3. Is that right? Question? A die is rolled 19 times. The number of twos that come up is tallied. If the experiment is repeated many times, find the standard deviation of number of twos. How do we do this? Some people in this class who keep emailing me and they just don't show up. It makes no sense. Hmm? Well, that's what I'm worried about. Like, I don't know what's going on. That's what asking me all kinds of them. But they need to come. I don't know where they are. Anyway, whatever. All right, what is this? Come on. What's the formula? We just wrote it down. Okay, it's kind of important if I just said that you need to know this, that you actually remember it, right? So write it down. All right, now, how are you going to get the answer? All you have to do is say what N, P, and Q are. Is that correct? So, like, don't tell me this is that hard. What's N? Okay, that should be really easy. Is that right? Okay, what's P? 1/6. What's Q then? No, 5/6. Does that make sense? It's always 1 minus B. Probably a failure. Does that make sense? What's the chances you don't get it too? 5/6. Is that right? So then this is going to be what? Square root of 19 times 5 all over 6? It's like 10/6 or whatever. So it's like around 5/3. I got this 1.6244, whatever. 1.6245, sorry. Does that make sense? Determine if the outcome is unusual. Consider that an unusual event differs by a mean for more than 2 standard deviations. That is unusual values for these things. We already said that before. Survey for this company determined that 68% of the consumers have heard of Dell Computer Company. If a survey of 800 selected for such groups of 800 would be unusual to get 606 who recognize. Okay. So then the first thing we should do is we should determine what the mean is, because they say mean here. In this case, this is binomial because each time they're saying 68% and they're selecting 900 people. Does that make sense? So the mean is just n times p. So that's 800 times 0.68. So what is that? 8 times 8 is 64. Carry the 6 is 48 is 544. And then this is now, then we need a standard deviation also, right? That's root NPQ. That's root 800 times 0.68 times what? Times what? 0.32. And then this is this 13.193938, whatever. All right, so then if I do the mean plus 2 times the standard deviation, and then I do the mean minus 2 times the standard deviation, right? To get the maximum usual value and the minimum usual value. Is that right? Right? What do you mean, what is it? Read the question. Plus is the same thing we talked about before. So this is what you said, 544 plus 2 times this thing, and then minus, we get those two, 573.89. And 517.6, whatever. 1, 2. Does that make sense? Does that make sense, guys? How do you answer the question? That would be unusual. Did I even need to do all this? What did I not have to do? Second thing is correct. Good. This is useless here. We already said the maximum usual value was 570. Is that correct? Is 606 unusual? Yes, because it's bigger than this. Does that make sense what I'm saying? If I say the maximum usual thing, right? You usually get between here and here, right? Is this unusual? Say with money, it's simpler. Does that make sense? The guy usually has between 517 and $570. Does that make sense? Someone shows up today and they have $606. No, it's unusual. Is that correct? Does that make sense? Question with this? So if you get one of these are not bad. Does that make sense? All right. All righty. Any questions? Is everybody okay? All right. Then we good.